Welcome everyone to our fancy British video on the mechanism for the nitration of methyl benzoate. Let's begin. As my loyal lab partner Sam illustrates, with a lovely arrow, the lone pair of electrons on the oxygen atom form a bond with the hydrogen atom. He then takes his sweet time to draw the double reaction arrow and corresponding brackets, which will eventually show you the product of the hydrogen bonding to nitric acid. But who can blame him? After all, these mechanisms take forever to draw by hand. As I was saying, you can now see him showing the charges of each atom on the molecule, including the arrow pushing that the compound will undergo in order to become two separate, but more stable molecules. As the electrons from the oxygen-nitrogen bond move to the oxygen atom, while the lone pair of electrons on the oxygen atom to the right form a double bond with the nitrogen atom, as Sam denotes again, with a splendid double reaction arrow. This is the mechanism for the process that forms the nitronium ion, which will mainly be used in lab, as well as the water byproduct. But wait just a minute, I think it's time we address a few safety issues. Before moving forward, both sulfuric acid and nitric acid are highly corrosive and can cause severe burns, so don't go feeding it to your pet apple. In fact, it's best to keep all foods out of the laboratory, as contaminated food can become harmful if ingested. If you somehow manage to douse yourself with large quantities of these dangerous chemicals, then it would be best to use the safety shower, located outside the laboratory in the hallway. Your classmates should assist you in removing the affected clothing. Just don't be like this bloke and stare directly at your half-naked classmate as they wash. Methanol is used in this experiment, and it should be noted that it is flammable. In the event of a fire emergency, you should notify the TA and exit the building if necessary. A fire blanket is also located in the front of the laboratory. Remember to stop, drop, and roll. If you have spontaneously turned into a mannequin, I'm afraid it's too late, and no amount of rolling can save you now. Don't cut yourself with glassware, and remember to keep your station clear. And lastly, I'd like to remind you to properly dispose of all waste materials in their corresponding containers, and remember to keep your chin up. This lab won't take too long. Now we will delve into the second part of the reaction mechanism, which is the nitration of unsubstituted benzene. As Sam has drawn here on the board, the electrons from a double bond in the benzene ring attack the nitrogen in the nitronium ion, forming several cation intermediates shown here. It is important to understand that each of these isomers form at vastly different percentages. This is primarily due to the properties of the substituent group, as well as the temperature at which the reaction is carried out. For instance, the meta-nitromethyl benzoate product, which is being drawn here, forms in a majority of cases because its position in the benzene ring is that of the greatest electron density. The structure of the molecule attached to the benzene ring will determine this region of greatest electron density. And there you have the final products of this mechanism. I hope this experiment goes well for you all.